and record. So the distance formula. This is a very important formula. So it's actually just based off the idea of the, not the quadratic formula, the Pythagorean theorem. The a squared plus b squared equals c squared. So here with this, if I am given any two xy points, this is the change of x across here. So this could be like my second x value minus my first x value. Over here, we're talking about the change in y. So that could be y2 minus y1. Well, I don't want to square it just yet. So that would be the length of these sides. I'm looking for the distance between them, right? Or those side lengths. Now, to go between these two particular points, all it is the Pythagorean theorem. So Pythagorean theorem says, thank you, a squared plus b squared equals c squared. Hey, Mr. Engel, you looking for some? Okay. Cool. So a squared plus b squared equals c squared. So here, this side length here, that's going to be our c squared. Now, I got to square this and this together. So that gives me the distance formula that we're talking about here. It's really hard to see this, but it's going to start out. I'm just going to write right over this. x2 minus x1. Actually, let me just write it right here. So distance is equal to, going to start with x2 minus x1 squared plus y2 minus y1 squared. So my change in x squared plus the change of y squared will give me my distance squared. But how do I undo squaring something? What's the opposite of squaring? Okay, it's been a little while, I get it. It's the square root. So, hey, this formula looks big, right? You don't have to remember how it came to be. All we have to remember is what it is. Hey, this right? So this is the distance formula. So we are going to quickly practice this. Look, showing your work. I still need you to write down or type out what you're putting into the calculator. I get once you got it and you got it plugged in, we can take this entire piece, put it in decimals, and it will spit out an answer for us. So let's take a look here. So we got two examples here. So I'm going to write it at the top. I'm actually going to write a little fancier at the top here and say distance is equal to the square root of x2 minus x1 squared plus, now I have y2 minus y1 squared. So what I'm going to do is I'm going to start by labeling my points oh, this is X1, this is Y1, this is X2, this is Y2. Now, I know many of you will probably be able to drop the labels after today. I'm probably going to keep adding them for this week just to drive home that point, but you don't always have to label them if you figured out, oh, that's the pattern. So remember, our points always go X, Y. So I'm going to call the first point X1, Y1, X2. Oh, wait, I got my colors off. Sorry. So first point was X1, that was cream. Y1 I have as purple. X2 and Y2. Does that make sense how the points are essentially labeled? Now, what I'm going to do is plug them into their appropriate spots. Anything I wrote in black in the formula has to be there each time. So for this, distance equals the square root and then parentheses. What's my X2 value here? 6, so just plug it in. Minus, what's my X1 value? 3. Close parentheses squared. Plus 1, that's my Y2 value, thank you for that. And then what's my Y1 value? Close parentheses and squared. Now, here with this, if you want to start simplifying in there and following PEMDAS through, you can. But let's make life easy. We do have a good and powerful calculator that we can utilize. So that's what I'm going to do. Let's go to Desmos. There's my graphing calculator. And my goal, come on, you can load. My goal is I'm going to type this in exactly how it's written. Okay, something went off there. Let's try again. There we go. So I'm just going to start with the square root. So the square root symbol is found right here at the bottom of the keyboard. Then it says parentheses 6 minus 3. And then to do squared, I can hit A squared right here, or you can hit Shift 6 and then put a 2. It doesn't matter. Plus, that says parentheses 1 minus 5, close parentheses, and square it. So we did all that, and we get 5. So the distance between those 2 points is 5 units. I'm saying 5 units because on the XY grid, I don't know how long each unit is, right? I don't know if it's inches, centimeters, miles, meters. So I just said units. So all I do is type it in. And we get that it's equal to 5. Not too bad, right? Let's do the next one. Now, the next one, we just have to be careful with our signs. I threw some negatives in here just to make sure we're careful with things. So let's get started with this one. Distance is equal to, I'm going to do the square root. Oh, wait, I did not write. Let's start. What's my X1 value here? It's going to be -2. Now I have my Y1 right behind it. Then I have X2 and Y2. So what should be the first number I'm plugging in here? x2, which is 3. So I'm going to do 3 minus, now what's my x1 value? Okay, here's where 90% of your mistakes are going to come. You are right in saying it's -2. Most of the time, I see students make a mistake on this. The minus is part of the formula. I need to say minus a -2. So I had those back-to-back signs there. 90% of you that make a mistake here, this will be your mistake. You literally will just forget the negative sign on the 2. It's not like you don't know what you're doing. You just made a small mistake. Squared plus, let's keep it going. Now, what's my y2 value? -4 is correct, so I include that negative sign. And it says minus, what's my y1 value? 6, good. So, here, let's type this one in. Well, that is a little more writing, so okay. Again, the square root symbol is located right down here. So I can hit that. I have parentheses, 3 minus a -2. So I put those back-to-back sides in there. Squared, if you wanted to rewrite it as a plus, that'd be okay as well. Plus -4 minus 6 squared, -4 minus 6, close parentheses, and squared. This one did not turn out very nice, did it? Just give me 2 decimal places. A lot of these answers will be decimals. The first one I did intentionally pick numbers that would give us a whole number, but a lot of distances will be decimals, and that's okay. So that gives me 11.18 as my distance. So this is literally just utilizing a formula. Do we have any questions on the distance formula right now? Was that, I guess, still a question or you're good? Okay, just want to make sure. Okay, so there's my distance formula. The next formula we're going to look at is our slope formula. Slope is just the rise over run. Change in y over change in x. So to find the slope, remember when we did slope, when we were graphing, it's like, oh, my slope is 2/3. I count up 2 over 3. Well, that gives me the formula that follows right here. So this formula right here is my slope formula. M is the letter we typically use for slope. That is equal to y2 minus y1 over x2 minus x1. Now that formula should feel pretty familiar, right? Distance formula, I know we might have seen it in the past, but not as much. Slope we've definitely seen before. So let's take a look at some examples utilizing the slope formula. So again, M is equal to y2 minus y, actually, what was my coloring here? Y, blue, purple, red, green. I'm going to keep my coloring scheme the same. So So they're both going to be subtracted. So coloring scheme was blue then purple. So that's going to be y2 minus y1. And then that's over x2 minus x1, so red and green. So again, I'm going to label the points. If you're saying, Isaac, I get which points which, I don't need to label them, great. I know some people still need that, that's why I'm still doing it. So my first point will be x1 Thank you very much. I'll see your attendance in a minute. X1, Y1. So I have the color right. Yes, I do. Then I have X2, Y2. So now, again, I'm just going to put this in. This one's not going to be too bad to do on our own. We can also utilize Desmos. Now, slopes I always want to leave as fractions. So, M equals, what's my Y2 value here? 1. What's my Y1 value? 1 minus 5, okay? Over, what's my X2 value? And then my X1 value. Now, with this, we can look at this. This isn't too bad to do in our heads. What's 1 minus 5? 6 minus 3. I'm just going to leave it as negative 4/3. Now, if you're saying I'm not a big fan of doing the math in my head, let's utilize Desmos here. Watch this. I'm going to type this exactly how it looks. Now, I'm going to show you how to do this right. The first thing we want to do, since it's a big division, is I want to hit divide to create my fraction. 1 minus 5 over 6 minus 3. Now, it is giving me a decimal here. If I hit the little fraction button right here, there we go. It turns it into a fraction, negative 4/3. What you don't want to do here is type it the following way. 1 minus 5 divided by 6 minus 3. How I wrote this, does that look like how it was written down on the paper? No, so that's no good. That's the cool part about Desmos is when you write it, if it looks like how you wrote it on paper, you probably typed it in right, okay? Unless you did something wrong on the paper, but I made it look like it does on the paper and we're all good. Any questions about that one? Let's take a look at the second slope problem. So again, I'm going to label my points x1, y1, and that is x2, y2. So I know here again, m equals, going to do y2 minus y1. What's my y2 value? Negative 4. Don't forget the negative sign with it. What's my y1 value? Okay. What's my x2 value? Oh, x2. 3. And then what's x1? So I still want that minus and the negative 2 there. So did a great job confirming those back-to-back signs. It's what we wanted. F4 almost looks like an 11. Let me fix that. -4. And make sure that, yeah, there we go. Now that looks neater how I wrote that. Let's again quickly put this in the calculator. So I hit the divide before I do anything. -4 minus 6 over 3 minus a -2. And this one gave me -2 as the answer. So here with this, if we did it by hand, that'd be -10 divided by 5, which is indeed -2, like we just saw in the decimals calculator. I do need to see you if you're saying, but I'm just using the calculator to calculate each of these. I still need you to write down or type what you put in the calculator. That is showing your work. That is showing me how you got it. The how you got it is more important than what the answer is. So that's slope. Let's take a look at midpoint. Midpoint's actually a really easy formula. If I want the middle between two numbers, what might you do with them? If I say, hey, I need the middle between, let's say, 0 and 10. How would you find the middle between 0 and 10? They're 10 apart, right? Divide by 2, that gives me 5, right? If I said I need the middle between, let's go 4 and 6, how can we find that? What's in the middle between them? Can add them up, right? 4 plus 6 is 10. Divide by 2, we get 5. The middle could be the average, right? That's all the midpoint is. Midpoint is the average of the x's and the average of the y's. So average both x's and y's. So what it's going to look like is x1 plus x2 divided by 2, comma, y1 plus, let's write that wrong, comma, y1 plus y2, all divided by 2. That's it for midpoint. Average your x's, average your y's, call it a day. So it's located in the middle between both the x coordinates and the y coordinates. Let's take a look at it in action here. So again, my formula. Okay, so use x's red and green. Green and red, sorry. Keeping my colors consistent. So x1 plus x2. And I should have purple and blue. Perfect. Then y1 and y2. close my parentheses. So I'm just going to do X first, then I'm going to do Y. So again, my values here, X1, Y1, X2, Y2. Yeah, just leave the door open so I can kind of see inside what you pass. So X1 plus X2 divided by 2. That's where we're going to start. So that gives me 3 plus 6 divided by 2, comma, black part yet. Now I'm going to do Y1 plus Y2. One of these is going to be a decimal, the other is going to be a whole number. Not a big deal. So that's going to be 5 plus 1. Now here again, I could just quickly type these in to my calculator. I'm just going to do it in 2 parts, the X part and the Y part. 3 plus 6 divided by 2, that gave me 4.5. Now I do my other part. My Y part will be 5 plus 1 divided by 2, and that's 3. So I get the point. Now this answer will always be an XY point. 4.5, comma 3. So if we looked at that on the graph, we would see that is in the middle between those two. Got one last example that I'm going to give you guys the rest of class to start this practice and get help, get support, whatever you need, okay? Last example here. Again, label it X1, Y1, X2, Y2. So here's what I'm going to do. Again, I'm just going to plug in X1 plus X2 divided by 2, Y1 plus Y2 divided by 2. So please just again be careful with your signs. So it's going to start out. My X1 value is -2. My X2 value is 3, comma, then Y1 plus Y2. That's going to be 6. Plus a -4. Now it's a matter of just putting both into the calculator. Then treat them as 2 separate little problems to do. -2 plus 3 divided by 2. So that one gave me 0.5, so 1/2. And the other is 6 plus -4, all divided by 2, gives me 1. So here I get a point of 0.5, comma 1. And that's it. So slope, distance, midpoint, these notes will be posted along with this recording in just a little bit. Stop recording.